biopharmaceuticals science to evaluate disruptive technologies such as machine learning trained imaging pipelines for cell selection. During the COVID-19 pandemic, she became passionate about large-scale policy interventions to address biological risks such as pandemics and respiratory pathogens. After co-founding a grassroots advocacy organisation for biosecurity, she now leads the UK strategy for One Day Sooner as Director of UK Advocacy on use of human challenge trials and building medical countermeasures against biological threats. Jasmin is also a fellow with the Aspen Institute Rising Leaders Programme and Global Shaper with the World Economic Forum. If you would like to add questions for the end, that would be great. And without further ado, here is Jasmin.
Thank you so much, Shay. Hi, everyone. Really lovely to meet you. Let's jump straight in, and I'm really keen and looking forward to the Q&A at the end, where we probably get to interact a little bit more. I will just share my screen so you can see my presentation. And hopefully that is visible. Great. So let's jump straight in. As Chase already mentioned, my current role involves leading the UK strategy for an organization called One Day Sooner, where we evaluate mechanisms on how to accelerate the countermeasure development and initiatives for policy and regulators to prepare for the next outbreak. For the purpose of today's presentation, I've kept it less so on what I'm doing at One Day, but more generally the landscape of biosecurity risks that we expect to be emerging in the next few decades, and what are some potential risk mitigation strategies we could be adopting to manage them. So the presentation, I'd say, roughly has a structure of 3 parts. We'll start with what I think is the current pandemic fatigue stage we're entering in or tend to be living in, and why it's really important that we're tackling this head front. The second structure here to touch on are kind of a quick overview of the broad landscape from which some of these biological risks seem to be emerging, whether they tend to be naturally occurring or more engineered deliberate risks. And the third part of the presentation will touch on what are some risk mitigation strategies and management strategies we could look into the future for. Touching on what we think is the current pandemic fatigue stage, there was this excellent paper by the World Bank in 2019, just before the COVID-19 outbreak initiated, which touched on these 4 to 5 different stages of what they expect the panic to neglect cycle tends to be. So based on how the current funders, the regulatory environment, and the academic communities tend to be shifting, there's a lot of pandemic fatigue about funding a lot of these risk mitigation strategies, and generally where the world tends to be heading on whether we should be thinking about pandemics more or less, and the respiratory management side. During the COVID-19 outbreak, Science Direct, which is a great publication, analyzed these stages in more detail and published these stages at the bottom, roughly indicated in yellow, which indicated that usually during the beginning of a pandemic, there tends to be a lot of negligence from governments or overarching bodies, and usually denial about their ability to manage these emerging pathogens. This then, of course, spirals pretty badly as the transmission rates tend to pick up and health institutions start to become really overwhelmed. This often shifts us back into a stage where more of the response mechanisms tend to be deployed, but they also tend to be ineffective and are usually pretty badly planned. And that pushes us back into the last stage where, as we transition outside of a pandemic, even arguably, usually in first world countries, a lot of these investments and risk mitigation strategies tend to be scaled back, and we enter a sort of an inter-pandemic period that I'd say we're in at the moment. But it's really, really important that, reflecting on the lessons and the experiences that we had from COVID-19, we are very forthcoming and advocating for better template protocols for how we expect to manage all emerging risks. Usually pandemics can be classified in category of risk that we called GCBRs. I think there's a lot of different definitions out there of GCBRs, and I expect some people here already might be familiar with this concept. But just as a recap, the definition that I tend to defer to, very well put together by the team at Nuclear Threat Initiative, is GCBR is often a biological event that could cause severe damage to human civilization, potentially derailing or threatening its long-term survival. So pandemics is not a new concept for us. We've been living and managing them for decades and decades as human civilization has evolved. But there's often the expectations that given the emerging risks from biotech, increased biotechnology availability around the world, there might be a lot of motivation for these GCBRs, for pandemics to become a lot worse than they were for COVID-19. Looking more into the emerging risk landscape for where we think these biorisks might be coming from, I'd say we can roughly try to classify this as two categories. So one is our naturally occurring and the other are engineered risks. In terms of naturally occurring, this is not going to be a surprise for anybody in the audience. The whole lifestyle for how humans have been living from the past few decades has drastically shifted. So one obvious culprit here to blame is climate change and how it's affecting the increase in zoonotic transmission for a lot of these viruses. Another risk to really keep an eye out on is, to this point, experts believe that we only know less than 4% of respiratory viruses that are out there in the world that could be a zoonotic risk at some point. But for even the 4% that we do understand, we have very, very little information on their mutations and how that contributes into potentially more transmissible zoonotic transmissions as well. The other thing to touch here is, of course, increase in population at a booming rate and how that factors into globalization, expanded trade routes. It is now much easier for any pathogen from getting from one part of the world to the other, which of course makes it really hard for bodies who are thinking and preparing for these pandemic risks altogether. The other I'd say like we still expect that zoonotic transmissions are going to be something to keep an eye out on as we think about GCBRs and how to prepare for future outbreaks. But usually for naturally occurring outbreaks, there tends to be somewhat of a trade-off hypothesis, which is that if a virus is very, very fatal, it's unlikely that it's going to be very transmissible because as logic dictates, it's very difficult for a virus that kills its host very fast to be transmitted from one host to the other. But here's when things get quite weird when we look into pandemic or engineered viruses, because for them, it's actually very possible via mutations or gain of function research, for example, to ensure that any pathogen that you're creating could both be very fatal and also very transmissible, which of course makes the risk management profile much, much and significantly difficult. And if you're trying to think of an example here as a mental case, I recommend like thinking of Ebola, but like much, much worse. Thinking about how these risks could be classified, I'd say I roughly think of them categorizing them in these broad categories, and especially distinguishing them between what we might call deliberate misuse versus accidental. So accidental risks, this could range from lab leaks that might be occurring from biosafety labs at level 2 or level 3. Biosafety labs 4 tend to be much more highly regulated, controlled, and a bit more scarce. But based after COVID-19, there has been more investments recently to build more BSL-4 labs around the world. There was this excellent paper by King's College London evaluating and mapping how many BSL lab facilities there are around the world and how well they're currently being managed. So I highly recommend a quick Google search for that paper. Thinking about deliberate misuse, there are a lot of actors. We know in the past there have been certain cult groups in Japan, for example, who have been motivated to engineer pathogens and release them to achieve fertility or what they called end of civilization. Sometimes and definitely in escalating political risks, I don't think it'd be too crazy to expect that there might be states or actors motivated here to utilize some of these biological weapons. So these are generally what I classify as the risk landscape for naturally worsening engineered. And something I think it would be amiss to not build on this, given the recent developments in the world for us, is a little bit more of a case study for what I'd classify under deliberate misuse of an engineered pathogen. So I'd say the AI conversation and how that feeds into biorisks has been pretty interesting, but also a scary thought in the last few months. I do feel it's still pretty nascent. There's a lot of publications that are still emerging. But one paper I would highly recommend, and I've put a QR code here if somebody's interested, was a paper done by the Center for Long-Term Resilience here in the UK, which did a preliminary analysis for what they expect some of these risks to be from large language models and also biological design tools. So there's generally the expectation that as this technology develops further and becomes cheaper, more accessible, that some of these language models and analysis and data tooling models could contribute into how easy it is for someone to get access to information on how to develop a pathogen, which could cause severe harm and it could be fatal for the human population. Um, and I generally say that these the risk landscape or the balance that we're playing here is between AI platforms that are being used in the world right now to heavily invest in vaccine platforms that allow us to create vaccines that are broad spectrum against all emerging pathogens, but also to make sure that we can create vaccines that are more stable. But the other downside risk is, of course, how this information could be misused by certain motivated actors. So I think it's important to keep both of those profiles in mind as we're thinking about these risks. As yes, AI in biodevelopment could also be very beneficial for how we manage global health and health security around the world. But it's really important that academic institutions, labs, and pharmaceutical companies who are investing in this technology are creating the governance structure to manage these risks really well. The shifting gears a little bit on from moving on what we think are the landscape for these emerging risks to how we could potentially mitigate some of these risks as well. I think there's a lot of mechanisms out there, and each of them have their benefits/caveats or limitations as we scale them from one country to the other. And there's generally a lot of good podcasts and publications, as in the EA community, for what these mechanisms could be. A general framework that I try to think about and how to classify this is one that was proposed by Kevin Asphalt in a 2022 report that he did that I thought was very concrete and nice to classify these things, is a prevent, prepare, and respond framework. Usually when we're talking about prevention, the idea here is that mechanisms that allow us to address the root cause for any outbreak that might be occurring. The prepare generally tends to be strategies or investments in place that allow us to improve our readiness factor for if an outbreak does happen, how we manage that outbreak and its impact on human civilization. And generally, the response tends to be how we can contain an existing outbreak or an evolving one and make sure we minimize the impact as much as possible. So focusing a bit more on the prevent side, there's been a lot of proposals on how we can build incentives for all the stakeholders that are working in this space to better align on prevention and really make it a priority. I also do believe that any investments in prevention are likely to be much more impactful in how we protect the human civilization and One Health approach than general response mechanisms in the future. So I really think this is like an area that demands more attention and investments from any actors that are interested in tackling this. So some of the interesting discussions that have been around is proposing a pandemic test ban treaty, and the idea kind of stems from the nuclear ban treaty that a lot of EA and other actors have been working on. And the idea is to deploy a treaty where stakeholders around the world are incentivized and ensure that they have the buy-in to prevent any deliberate misuse and research of a pandemic pathogen. Another interesting idea that was proposed in some of the conversation was the idea of a liability insurance for catastrophic outcomes. And the idea here, on the underlying foundation at least, is that if somebody is spreading these risks around the world, then they should be held accountable. So if we take biosafety lab, for example, and assume that there in the future there might have been leaks from a BSL level 3 lab, which has significantly affected the people or the populations living around that lab. It's important that that lab is held accountable, and whether that's they're paying compensation for the impact that they've caused, or whether that's the insurance mitigations they have in place. And this needs a lot of evaluation. I also think this idea is like fairly early, but has been proposed in some of the meetings I've recently been in. So yeah, I think this is generally a really interesting one to look into as we look into sort of governance structures and global mechanisms. The third idea here is ensuring that we have really strengthened screening in place for any unwanted DNA synthesis. There's been a lot of work in this. I'd even say a little bit biased here in the new biosecurity strategy that was put forward by the UK government, released earlier this year in June. There's a lot of emphasis on tabletop DNA synthesis screening mechanisms and ensuring that labs, for example, or pharmaceutical companies that are working with dangerous pathogens and sequences, when order these from producers have really comprehensive checks in place to make sure that this cannot be misused by any actors. I'd also highly recommend recent papers and publications by the Nuclear Threat Initiative on DNA synthesis screening, which have been really, really interesting. And I think there's usually a lot further ground here to get this implemented in the US at the moment, maybe in the next 2 years. So we're waiting to see how far we're getting with DNA synthesis screening. The next section, I'd say in the risk mitigation that's worth touching on is prepare, where we generally enhance our readiness from these emerging outbreaks. One really useful and cost-effective intervention here recently has been detection capability. It's really great to see that more countries around the world are now really buying into the idea of how useful wastewater surveillance can be. Wastewater surveillance has not been a new concept. For example, in UK or specifically in London, we've used this technology in the past to look out for polio outbreaks that might be emerging in different constituencies around London, for example, and how that could be managed. But after COVID-19, it's really great to see more investment and ramp up in these capabilities, and also from a more pathogen agnostic approach, which is going to be really, really important. Most of the time, when we're thinking about these catastrophic risks, we generally don't know the profile of the pathogens that we're dealing with or potential variants that might go unmissed because we don't know what to look out for. So technologies like metagenomic sequencing, for example, could be really powerful tools here to make sure that we're keeping an eye out on all biosamples that are appearing in these sites. A lot of good work here also in the US to ramp up wastewater surveillance. And I'm excited to say that some of the past meetings I've been in the EU, there's been a lot more talks starting from Switzerland and Belgium, and now HERA, which is the body within EU looking at pandemic risk management, are also incentivized to make more further investments to ramp this ability around Europe. What I'd like to see, I think even more, is to see this spreading into the global south, because I think a lot of these hotspots for these emerging viruses tend to be concentrated there. But it's also important that high-income countries here are willing to share these investments and make sure we're scaling them outside of just the Western front. The other general category of risk mitigation under prepare, I think worth mentioning, is this idea that has been floating around for the past 2 years, especially after COVID-19, is a central repository or library of medical countermeasures. I'd say a lot of my work at the moment focuses on this. And we've been working on evaluating how mechanisms like human challenge trials, where volunteers are deliberately infected with a pathogen to determine immunity or correlates for protection, could be used to accelerate this global countermeasures library. But something that's like really worth highlighting here is the 100 Days mission that was proposed by a body called CEPI after the G7 presidency that UK hosted in 2021. And the idea is that, we really should be, as a society and world, trying to hit this objective that no matter which pathogen emerges or from where, we should be in a position to bring that under control in 100 days or less. There's been a lot of skepticism, I'd say, in even in some experts group on whether like 100 days is a target that's possible or not, if we're like really overstretching or being naive. But I would like to think that I tend to fall a little bit more on the optimistic end, which is that if a lot of these mitigation and prepare and prevent strategies that I just touched on so far, if we're really able to build a really good ecosystems for how these technologies work together, where we have really good detection in place and we're able to ramp up a lot of the vaccine development and clinical trial facility in parallel as we're seeing these risks emerge. I think this 100 days mission target is something that we should be able to hit and should be trying to hit as we think about what structures to put in place in the current interpandemic phase. And I highly recommend for anybody who's interested in this 100 days mission target to look more into the work that CEPI is doing here as well, including a lot of the investments that they're making in building facilities around the world, including LMICs, to make sure there's really more equitable solutions possible for these pathogens around the world. There's also been a lot of good work, I'd say, by WHO so far on mapping what we think are going to be priority pathogens that we should be focusing more efforts on, or as more commonly known, a disease X scenario. Currently, and I expect this will be published at some point early next year, WHO has been working on updating their list for top 10 priority pathogens around the world that demand the most attention for the preparedness countermeasures that the world should be developing. And these top 10 pathogens, I expect most of them are going to focus on respiratory pathogens, where we think a lot of these risks might be for a more global catastrophic pandemic going forward. And maybe a rough flag is we also expect like UK, who has been working with WHO, and we've been also having some interactions with our work at One Day Sooner. UK are also like to publish their updated list at the end of this year. The last category to touch here in risk mitigation is the respond framework. And PPE, I think, is like this really, really worthwhile and cost-effective and useful solution, especially when we think about pathogen agnostic approach for these countermeasures. Something that's been sort of like an emerging issue with some of the PPE has been how design factors into how effective the PPE tends to be for different populations or different gender profiles, and how to ensure that the PPE is really like very concrete, especially for the frontline health workers, which tend to be the most vulnerable subsection of the population during outbreaks. A lot of good publications here, again, I'd say within EA and wider groups that work on pandemic health technologies, and I definitely recommend a quick search if you are more interested in PP going forward. The other The other thing that's really important for, I think, generally the world during a response framework is the resilience of supply chains. We know this was an ongoing issue throughout the COVID-19 pandemic, especially when we think about raw material for a lot of the antiviral and vaccines that LMICs needed in order to develop some of those vaccine portfolios. So it's really important that, we're actively monitoring where supply chains are operating, what are the bottlenecks and the weak points, and how we make sure we're strengthening these when we think about how to address these health inequalities going forward. The last sort of like category, I'll maybe like clump them together a bit here, is how population and individual response factors into how well we can respond to a potential biothreat. We know that, profiling different countries around the world, there tend to be a lot of disparity on how well the lockdown measures worked in some countries and some didn't. We also expect that, trust in governments and public health messaging was a big contributor to whether people were willing to follow these lockdown measures or not during COVID-19. Actually went to some meetings recently in the past 2-3 weeks with the UK health departments who mentioned that they've been doing a lot of analysis after COVID-19 into making sure that the public health messaging is a lot more concrete and trustable with communities, especially underrepresented ethnic minority communities going forward, to make sure this is as good as it can be during the next outbreak. And the last one I'd say, which I think has been like a really sort of like exciting area, getting lots of worthy attention in the EA community recently, is the potential for far UVC technologies to be deployed for improving indoor air and reducing pathogen transmission in close quarters. There's a lot of potential here, and I think the most comprehensive piece of analysis that we've done on this has been this report that we did with Rethink Priorities, which I'll put a QR code here if anybody's interested. But I'd say like UK is currently evaluating this to some very low profile and intensity, and there's been maybe a bit more excitement about this in EU recently. That's as far as I'm aware, but I do think there's a lot to be considered here on how we can make this technology more accessible and cheaper, because cost is a big bottleneck for how widely this could be implemented. And I think there's needs to be a lot more investment into evaluating the safety as well as the efficacy of the far UVC technology here as well. The last thing I generally wanted to touch on here is and I think tends to be sometimes a little bit underestimated or not mentioned enough in a lot of these health security or pandemic preparedness conversation, is the equity angle. There's been excitingly more recent individuals, I'd say in EA and widely outside of EA, who've been working on this issue with full force, which is like really beautiful and exciting to see. But something that really brings home this point for me every time was this sentence that someone said to me in one of my meetings a couple of years back, which is that you don't actually end a pandemic by developing a vaccine, you end it by actually vaccinating people. And I think this sentiment is so important as we think about what solutions we're creating, and more importantly, how are we scaling them to the rest of the world in a lot of these hotspots and the most vulnerable populations. Because we're not ending a pandemic until we've covered that approach. And I think for the WHO recently, they've been putting a lot of work and comms out there in advocating for this One Health approach, which not only has equity as one of its foundations, but also touches on mapping the risk profiles beyond just human populations, but also plant biology and animal health, and how that factors into some of these zoonotic transmissions that might be occurring. So I really recommend that as another potential resource for anybody who's interested in this space. But yeah, thank you very much. It was really privileged to be able to share some of my 2 cents here with you guys, and happy to take any questions that might be coming.
Great, thank you for that, Jasmin. That was fantastic. Yeah, so we have a couple of questions to start with. In your role as Director of UK Advocacy at One Day Sooner, could you share more about your work, the importance of advocacy, and what current plans you're excited about?
Yeah, thank you for that question. I'd say my role is varying between different mechanisms that we've been evaluating for pandemic preparedness, but maybe 70 to 80% of that portfolio is currently focused on evaluating how human challenge trials could be implemented in the UK, and scaling from there the work that we're doing with WHO. So, for context, UK was the only country that did human challenge trials during the COVID-19 pandemic. No other country decided to make that move. So I think there's a lot of like rich history here for UK to play somewhat more of a sort of like a leader in this space and see if other countries would be willing to follow suit. And the work that we've been doing is that the human challenge trials is something, is something we've been doing for decades and decades for a lot of endemic disease settings in LMICs and middle income countries and high income countries. But we've never used this mechanism for a pandemic pathogen ever before COVID-19. So there's a lot of unanswered questions and expectedly a lot of uncertainty on, for example, when it's even ethical to, deliberately infect a volunteer with a respiratory pathogen for which we still don't understand the long-term consequences for. And that's a very hard that's a very hard question to answer. But the other thing to consider here is that if we think about creating, next generation vaccines that not only reduce symptoms but block transmission, like that is so important. That's where we need to be heading as a society, along with vaccines that are resilient towards all emerging variants for a pathogen, along with being temperature stable. Like there's a lot of features that we need to improve in current vaccines. Um, it's really hard to get to those next generation vaccines if we don't have correlates or immune markers for mucosal immunity, for example, which you cannot get outside of a human challenge model in a pandemic. So we've been talking with most of the government bodies and health departments here in the UK, along with bodies like CEPI and Wellcome Trust, and more recently with the World Health Organization. And we're doing a lot of stakeholder coordination along with publishing academic papers and original research on how we think these models could be tailored for this priority pathogen list that I referenced that WHO and UK departments are working on. And the idea is that, we this global medical countermeasure library that the world or UK or WHO are building, we should be able to have much more advanced solutions in that medical countermeasure than the ones we're planning to make at the moment because they're just not good enough, or they could be much, much better quality. Um, and another like really useful thing we want to hopefully get done is de-risk a lot of these portfolios because we want, rather than making 25 antivirals for a pathogen, we want to make sure we get the top 5 or 3 that are the most effective and next generation, which is again where we think human challenge trials would be really, really useful. So that's like I'd say an aspect of the work that takes up most of my my brain space at the moment. But outside of that, leading the UK chapter, I also spend time thinking about, what role does a country like UK play for the rest of the world with what pandemic preparedness work we're doing? Like, what's our role there? What is our influence, and how do we scaling that beyond the UK at the moment as well? But yeah, I'll stop there.
Thank you for that. Yeah, following on from that, you were just saying about how this scales beyond the UK. Are there how generalizable is a lot of your recommended actions to more developing nations, for instance?
Yeah, that's a great question. I'd say a lot of the scientific synthesis we're doing at the moment on these respiratory and priority pathogens, actually a lot of those pathogens tend to emerge from different hotspots in middle and low income countries, and the global south, I'd say. Just given the temperate environment and kind of how the population and where population behavior tends to be. So I think if we're successful in getting at least one country like UK, which has been like the leader in challenge trials for like as long as we can remember, is hopefully like a great influence point and incentive for other countries to also make the same considerations. In the past few weeks, I'd say we've been interacting more with bodies like CEPI, who are like evaluating on how to build this infrastructure in LMICs so they don't have to rely on, well, essentially richer countries to share the data and share the vaccines and the antivirals, but can actually synthesize and build them themselves, which is, I think, so important going forward. So I'd say the advocacy element right now is a little bit more tailored to UK because we think we have like a more tractability success rate and we want to hit it. But the science itself is like very scalable, and we're taking the global perspective into a lot of the academic synthesis we're doing.
Great, thank you. And you were saying you have quite well. Your take is that you have an optimistic approach to how achievable some of this is, and CEPI's goal of 100 days. Could you expand a little bit on how you came to that assessment?
Yeah, I think like sometimes I think a lot of the I'm making an assumption here, but I think sometimes the criticism for things like the 100 days mission tend to come from the fact that like, we got a vaccine faster during COVID-19, but it was still nowhere close to 100 days. And that's gonna be the case because we're essentially fighting like a blind war. We don't know what we're preparing for. But I actually disagree because I think the idea is to not look at these mechanisms in isolation. Like vaccines alone are not going to end the pandemic. Wastewater surveillance alone will not end the pandemic. The fact that we should be heading towards is like in this ecosystem of risk mitigation for biothreats, how well do these mechanisms work in reciprocity? Like if we can hit that well, if we can synchronize those risk mitigations well, I think we can hit like 100-day timeline, if not shorter, I might say so. And I think like something important to highlight here is the fact that like one of the reasons we got the COVID-19 vaccine quicker is because we spent a lot of time in every year leading up to that researching pathogens like RSV and MERS and other variants of SARS. So it's like we had a lot of pre-existing information and templates and vaccine platforms that we could pivot for COVID-19 when needed and as needed, so that like inter-pandemic investment and preparedness is like super vital, and we can continue that investment and scale that up well. I think we can definitely hit a 100-day timeline.
Great, thank you. Yeah, and relating to that, uh, since the pandemic, there's been concerns about scientific fatigue and policy fatigue around these issues. This you have quite a optimistic, hopeful outlook, it seems, which I think is often a fairly good counter to some of that. Have you seen that? Is that an issue that you're concerned about?
Yeah, definitely. I think it's been like you see in like little things and you see in larger things. So when I say little things, sometimes it's just like hard to get meetings with the right policymakers because they've like mentally just moved on from COVID-19 and want to work on other issues. We've certainly seen that with some of the work we're doing here in the UK. There is generally like some pandemic fatigue in health departments. And we also seen it at larger scales. I think there was like a lot of independent and like more larger philanthropic organizations moving to fund this countermeasure development during COVID-19, which I think has like somewhat dried away a little bit. Not completely. I think there's still like a lot of exciting actors involved, but I'd say relatively it's less than it was during COVID-19, which I think makes it like a little bit harder for all the stakeholders and individuals who are working in this space. Um, so yeah, I think it is visible on both levels, but I think the reason I remain optimistic is because yeah, like we've also been like learning and constantly iterating with how we approach and get the right message across to the right decision makers so we can like essentially get stuff done. So and I think like some of the work that maybe WHO have been doing here with the pandemic treaty, and more conversations about equity and global South actors entering the space and pushing for more equity has also been exciting to see. Um, and yeah, I think like bodies like SEPI are continuing to make like further investments like multi-million into vaccine platforms and like single like RNA technologies moving beyond just mRNA. So like that exploratory research science space I think is like really exciting in how we utilize it going forward for these pathogens.
Great, thank you. On a slightly different note, in the framework you've given, prevent, prepare, respond, do you see this as something that has a lot of trade-offs within it to address these, or is it something that you feel can be addressed fairly overall collectively?
Yeah, sorry, just to hone in, like, what do you mean by trade-offs? Is it downside
So
risks
between
or?
these different areas, between whether we focus on prevention policy or um, response issues, yeah.
Yeah, I'd say that I'm gonna be like quoting like the NHS or what doctors say here, which is like prevention is always better, than treatment. And I do think that in terms of like the likely impact for these risk mitigation strategies, I always think prevention is a one, that we should really try invest more in because it's always like cheaper for the society in terms of like human health and like the amount of money that we might end up spending in like a response scenario. So yeah, I think it's definitely the one to focus on. But yeah, I think as I was trying to indicate a real challenge with I'd say with a lot of these like prevent and even preparedness response risk mitigation is that you kind of like don't know which pathogen you're preparing for to some extent, especially in the current space that I'm in the prepare scenario where yes, like we're able to pivot some vaccine platforms to like different genus of viruses within the same family, for example, but some of them tend to be like so different in their biological makeup that it's not always that generalizable and it's you can't always pivot it as required. So that makes it like really challenging to kind of like plan and prepare for some of these outbreaks. But I'd say like as we're investing more time and research into mapping like which are the priority viral families we need to focus on, and then these are the expected symptoms or risk profiles or case scenarios, I'd say that space is getting like less foggy, and we're able to do more. But yeah, both of these needs to happen in reciprocation. Like it cannot exist without the one without the other.
Absolutely. Great. Thank you. And what advice do you have for individuals who are looking to build a career in this space or in biological risk issues? There's generally a view that maybe that you need a scientific or medical background to address a lot of this. Do you agree with that? And if not, what can non-biological sciences background, for instance, contribute?
Yeah, you definitely don't need a scientific background to be like a really effective person in this space. I think we have like we're very like hungry for like a range of talent in this space. And I say like in the kind of the sector or space that I work in, which is like policy for biothreats. Yeah, like 80% of the people I meet don't have like sort of like a concrete scientific background, but just like a really effective policy mobilizers in the world. And they come from like a range of backgrounds from like languages, history, art, all the way to like PPE or politics. So I'd say it's really varied. Maybe that changes a little bit if you're very motivated to like run a lab or to like kind of work a bit more kind of hands-on research. But again, I think a lot of the skills can be acquired. I think there was an EA post recently which was kind of like low cost things people could try if they wanted to test their fit for biosecurity. So I'd really like recommend like some of the items on that list as people who are like wondering if biosecurity is for them. But I definitely think you don't need like a technical background. I think maybe for me, like it was somewhat more sort of like a natural evolution over time. Like yes, I did have a bio background. I was a biochemist by training. And for me, like I'd say it's been helpful to have that in the policy world because it signals a lot of credibilities with certain decision makers we're working in. It's always helpful to like understand some of the monoclonal antibody and vaccine stuff that experts talk about when I walk into these meetings. But I've worked with people even in our organization who are like just really, really effective at this, but don't have a scientific background and just kind of acquire this over time. So yeah, short answer, no, you don't.
Sure. Thank you for that very much. And that's all of the questions I've got. Do you have any closing comments you want to make or anything you'd like to further address?
Yeah, no, I think like yeah, it's been really like nice and privileged to be able to do this and share some of my experiences and thoughts on this. And yeah, like really excited to hopefully see more individuals from sort of like a non-westernized world context come into this space and push it forward. I'd be really excited to see that. And yeah, if anybody has any questions or thoughts, please do reach out to me and I'm always happy to connect.
Yeah, well, thank you so much for that, Jasmine. That was great. Really appreciate you coming along today.
Thank you
Yeah,
so much.
thank you, everyone. That's the end of the talk.